Now this is exercise 7D, laws of logarithms continued. This is part 2. So up to question 6. Express each logarithm in terms of log to the base 2 of 3 and log to the base 2 of 5. And you just also need to remember that log to the base 2 of 2 is 1. So log to the base 2 of 18. We have to think, how can we form the number 18 using 3, 5, but we've also got log to the base 2 of 2 that we can use. Now we know that 18 is 9 times 2. Okay, so log to the base 2 of 18 is the same as log to the base 2 of 9 times 2. Now I'm going to break that up, and I know that I haven't used a 3 yet, but we're going to use that in a minute. So that's the same as log to the base 2 of 9 plus log to the base 2 of 2. Now we know that log to the base 2 of 2 is 1, but we only know the value. We want to express, this in terms of log to the base 2 of 3. Now we know that log to the base 2 of 9 is the same as log to the base 2 of 3 squared. And we've also got log to the base 2 of 2. Now, log to the base 2 of 3 to this power 2, remember this power, using the law that we looked at in question 5, where we've got log to the base a of x to the power of n, we bring the n to the front, okay, of the logarithm. So here, this 2 can come down to the front, so 2 times log to the base 2 of 3 plus, now we know that log to the base 2 of 2 is 1, so I'm just going to replace that with a 1. So now we have expressed log to the base 2 of 18 in terms of either log to the base 2 of 3 or log to the base 2 of 5. Okay, similar question here. So you've got to think what two numbers multiply to give 20. We've got a few choices. We could use 10 times 2, or we can use 5 times 4. 5 times 4 is a good one to go with, because we're trying to express the log in terms of log to the base 5, or log to the base 3, or log to the base 2. So log to the base 2 of 20 is log to the base 2 of 5 times 4. We can split that up using the log law. So that's log to the base 2 of 5 plus log to the base 2 of 4. So this bit's done, okay, but I need to change the way. I don't want to express it in terms of log to the base 2 of 4. But we know that 4 is 2 squared, so this log to the base 2 of 4 becomes log to the base 2 of 2 squared, because 4 equals 2 squared. Whenever you've got your power, you need to bring that down to the front. So that 2 comes to the front, so it's 2 times log to the base 2 of 2. So this is log to the base 2 of 5 plus 2 times, now log to the base 2 of 2 is 1. So this ends up equaling log to the base 2 of 5 plus 2 times 1 is 2. Now for the last question here, log to the base 2 of 2/3. So here we would use the division rule. So this log to the base 2 of 2/3 is log to the base 2 of 2 minus log to the base 2 of 3. Okay, now we know that log to the base 2 of 2 is just 1, so it's just 1 minus log to the base 2 of 3. 19 follows on from the last question that we did. So in the last question, we were expressing these logs in terms of, say, log to the base 2 of 3, log to the base 2 of 5, and log to the base 2 of 2, but we weren't able to calculate the values, all right? However, in this example here, we've been given approximate values for these logs. So given that log to the base 3 of 2 is 0.63, or approximately equal to that, to do decimal places, and log to the base 3 of 5 is approximately equal to 1.46. We're using log laws to find approximations for these here. So log to the base 3 of 10 can be written as log to the base 3 of 2 times 5. And then we use our log law, so that's log to the base 3 of 2 plus log to the base 3 of 5. Now we know the approximate values of those here. Values of those, we've got log to the base 3 of 2 is 0.63 and log to the base 3 of 5 is 1.46, and just adding those together we get 2.09. Okay, now the next one, log to the base 3 of 2/5. So using the division rule here, that's log to the base 3 of 2 minus log to the base 3 of 5. We know that log to the base 3 of 2 is 0.63 and log to the base 3 of 5 is 1.46. So subtracting those, we get negative 0.83. Now the next one, you're going to have to think of the numbers that you might want to use. So we've only got log to the base 3 of 2 and log to the base 3 of 5. However, you can, remember, you can also use log to the base 3 of 3 if you need to. So if you look at 32, you really can't form 32 using the numbers if you're multiplying the 2 and the 5, because look, 5 doesn't go into 32. The only thing you could do is look at powers of 5, okay? So it's not always a multiplication or always a division. Remember, you've got the power rule, so we can write 32 as 2 to the power of 5. So therefore, log to the base 3 of 32 is log to the base 3 of 2 to the power of 5. Remember, with our log law, we bring that 3 to the front. So it's 5 times log to the base 3 of 2. Now we know that log to the base 3 of 2 is 0.63, so it's 5 times 0.63. Remember, this is an approximation as well. And we end up with 3.15. And the last one, log to the base 3 of 18. Well, we know that 18 is, now our only choices for 18 would be 9 times 2 or 3 times 6. Now we know what log to the base 3 of 3 is, but the thing is we don't know what log to the base 3 of 6 is. So the 3 times 6 option will not work. So you can try log to the base 3 of 9 times 2. The reason that this is good is we know log to the base 3 of 2, but we also know that 9 is 3 squared. So let's just apply this rule for multiplication here. So that would be log to the base 3 of 9 plus log to the base 3 of 2. Now we know that log to the base 3 of 3 is 1, so we can change this log to the base 3 of 9 as log to the base 3 of 3 squared plus our log to the base 3 of 2. So now this 2 can come to the front, so it's 2 times log to the base 3 of 3 plus log to the base 3 of 2. Now we're able to substitute for both of those. So log to the base 3 of 3 is 1, so it's 2 times 1 plus, and log to the base 3 of 2 is 0.63, so it's 2 times 1 plus 0.63, so it's approximately equal to 2.63. Use the log law, log to the base a of x to the power of n equals n times log to the base a of x, and this law here, log to the base a of a is 1, to simplify the following. Now, clearly with the power is going to come to the front, so that's 2 times log to the base a of a. Now we know that log to the base a of a is just 1, so it's 2 times 1, which is 2. Very similar to that one, except there's a 5 in front here. So this is 5 times, now log to the base a of a cubed, the 3 can come to the front, so it's 5 times 3 log to the base a of a. Now we know that log to the base a of a is 1, so it's 5 times 3 times 1, which is 15. And this one down here. Now we want to use this log law with a power. Now log to the base a of 1 on a is the same as log to the base a of a to the power of -1. Okay, because 1 over a is a to the power of -1. Now using that power law, that -1 comes to the front, so that's -1 times log to the base a of a, or -1 log to the base a of a, or just negative log to the base a of a. Now we know that log to the base a of a is 1, so it's -1. Okay. Now again, using that same law, okay, this is just very similar. We're just wanting to write each expression in terms of log to the base a of x. So this is just some examples from question 11. Now we know that log to the base a of 1 on x is log to the base a of x to the power of 1. And so that negative now, the power just comes to the front, so it's -1 times log to the base a of x, which is just the negative of log to the base a of x. Okay, question 11e. Log to the base a of x cubed minus log to the base a of x to the power of 5. The 3 can come to the front, so that's 3 times log to the base a of x minus, and the 5 here can come to the front, minus 5 times log to the base a of x. Now you need to think algebraically now. So that's 3 of those minus 5 of those. So these are like terms. So that would just be negative 2. So 3 of the log base a to the x is minus 5, log base a to the x. They are like terms. So at 3 minus 5, so you've got negative 2 log to the base a of x. Okay, now it has been written in terms of log to the base a of x. Now I stopped there, but I just want to show you what this is also equal to. Okay, that is also equal to log, if I'm reversing the process, it's log to the base a of x to the power of negative 2. So it's actually the same as log to the base a of 1 over x squared, right? But this is the answer here because we've been asked to express it in terms of log to the base a of x. Okay, so you would stop there. Some of you might think, well, why don't I just apply the log law here? So the other way to do it is log to the base a of x cubed minus log to the base a of x to the power of 5. Now, if the bases are the same and we're subtracting these two, that's just the same as log to the base a of x cubed over x5, all right? So that's using the division law for logs, all right, but just in reverse. So log that x cubed over x to the power of 5 is 1 over x squared. So that is just another way of doing the question. Okay, but in the question they did ask you to use the log law where you're bringing the 3 to the front. But this is just showing like terms and how you can subtract. Okay, and then I can put, you would stop here, but okay. So if I was to do it this way, the question was to express it in terms of log to the base a of x. I would then need to put this back in the form of x to the power of negative 2, and then I'd still need to bring the negative 2 to the front. Okay, so just showing you two ways of doing that question. Question 11H, just another example here. So we've got log to the base a of 1 over root x plus log to the base a of root x. So we can write this 1 over root x as root x to the power of negative 1. But we're not going to do that yet. Before we do that, 1 over root x is 1 over x squared. And I'm just going to write this other one. This square root of x is also x to the power of, sorry, that's not 1 over x squared, mistake. It's 1 over x to the power of a half, sorry. So remember, when you're trying to apply that law of the powers of logs, this is the law, log to the base a of x to the power of n is n times log to the base a of x. So I can't apply that law unless my logarithm looks like that, where I've got x to the power of n. I don't want to see square root of x. I don't want to see 1 over the square root of x. So you need to be writing square root of x as x to a power. You also need to write 1 over the square root of x as x to the power. At the moment, I've got 1 over x to the power. So again, I need to change the way that this looks, and 1 over is a negative power. So it's log to the base a of x to the power of negative a half, and this one here is log to the base a of x to the power of a half. Now, don't think that these are like terms. They're not, because you've got log to the base a of x to the negative half and log to the base a of x to the half. In another question, we did have like terms, but these are not because these bits aren't identical. Now we can apply this rule over here. So the negative half will come to the front. So we've got negative a half log to the base a of x, and plus this will be 3 times a half, which is 3 over 2 log to the base a of x, because here we're just doing 3 times a half, which is 3 over 2. Now we have like terms. I've got negative a half log to the base a of x and 3 over 2 log to the base a of x. So these are like terms because the log to the base a of x bits are identical. And we all know that like terms, you can add and subtract them. So you've got negative a half plus 1.5. Well, the denominators are the same. You can just combine the numerators. That would be 2 over 2. That is 1. So, or it's 1.5 minus a half. So it's 1 log to the base a of x, or just log to the base a of x. Okay? All right, now for question 13. So given that log to the base 10 of 2 is approximately 0.30, and log to the base 10 of 3 is approximately 0.48, we want to use the log laws to find expressions for these three things down here. Log to the base 10 of 2, actually it's 0.2 that we want to do. Log to the base 10 of 0.2, log to the base 10 of 360, and log to the base 10 of 1 on root 2. But we don't have a value for log to the base 10 of 5, but we do know that log to the base 10 of 5 is log to the base 10 of 10 divided by 2, which is log to the base 10 of 10 minus log to the base 10 of 2. So we can actually come up with a value for log to the base 10 of 5. So let's just work with that first. So log to the base 10 of 5 equals log to the base 10 of 10 over 2, which is log to the base 10 of 10 minus log to the base 10 of 2. Now, we know that log to the base 10 of 10 is 1, and log to the base 10 of 2 is 0.3, or it's approximately 0.3. So 1 minus 0.3, 0.70. So now I have an approximation for log to the base 10 of 5 as well. Okay? So now we can continue with the question. So we have to use the log laws to find an approximation for log to the base 10 of 0.2. Now we know that that is log to the base 10 of, now 0.2 is 2/10. Now we have to look at what we've got. Okay, I do have an expression for log to the base 10 of 2. So I know that that's 0.3, and I know that log to the base 10 of 10 is 1. I could do this a number of different ways. I'm going to show you one way first. I mean, look, you could simplify this and write 1/5, and we do have a value for log to the base 10 of 5. So that could work as well. Or you could just say that's log to the base 10 of 2 minus log to the base 10 of 10. So for a division, remember you subtract. Now log to the base 10 of 2 is approximately 0.3. And log to the base 10 of 10 we know is 1. So this is 0.30 minus 1, which is negative. Sorry, that's a negative 0. So you can't read that very well. So that equals negative 0.70. Okay, that's an approximation for log to the base 10 of 2/10. But some of you may have thought, well, you know that 0.2 is 2/10 or it's 1/5, and you might want to do it like that. Now that is log to the base 10 of 1 minus log to the base 10 of 5. Now probably I would have used the top method, okay? But remember, last lesson, we know that log to the base 10 of 1 is 0, okay? Log to any base of 1 so is 0, because we know that log to the base a of 1 is 0. So just using that rule that we saw last lesson, log to the base 10 of 1 is 0 minus, now log to the base 10 of 5 is 0.70, so now I'll put approximately. Now 0 minus 0.70 is 0.70, again the same answer as the first method. All right, we'll try the next example, log to the base 10 of 360. Okay, we have to think we can use log to the base 10 of 2, log to the base 10 of 3, and also we have an approximation for log to the base 10 of 5. So this one, I'm just going to look at a bit of a factor tree for 360. Now I know that 360, let's say, is 36 times 10. And I know that 10 is 5 times 2. And I know that 36, I'm just going to try and use things that I've got. I know log to the base 10 of 2 and log to the base 10 of 3. I know that 36 is 9 times 4. Sorry, you can't see that. And I also know that this is 3 times 3. 9 is 3 times 3. 4 is 2 times 2. Okay, so therefore I could say that 360 is, I've got 3 squared times 2 cubed times 5. Now I can go in and replace the 360 with that. So as I was saying, I could replace the 360 with that. So I could say that's log to the base 10. Look, there are other ways I can do this. This is one way. I could go 3 squared times 2 cubed times 5, which is log to the base 10. Remember, multiplying means I break it up by adding. Log to the base 10 of 3 squared plus log to the base 10 of 2 cubed times log to the base 10 of 5. So that's just a bit right. Okay, and I can bring my 2 to the front, so that's 2 times log to the base 10 of 3 plus 3 times log to the base 10 of 2 plus, sorry, this should be plus here, plus log to the base 10 of 5. Now I can just substitute. All right, now look, probably a lot of you won't think of doing it this way. I'm going to do it another way in a minute. 2 times log to the base 10 of 3. Now log to the base 10 of 3 is 0.48. Log to the base 10 of 2 is 0.3, and log to the base 10 of 5 is 0.7. So this is an approximation now, and so we just work out what that is, and we get 2.56. Now let's try another way. Probably most of you won't think of that way. Actually, it's probably not the best way. Why don't we think that this could be 360 is 10 times 36, so it's 10 times 36, which would be log to the base 10 of 10 plus log to the base 10 of 36. Now I'll keep working with 36 in a minute. We know that log to the base 10 of 10 is 1. Now we need to break up log to the base 10 of 36. So we'll go, look, 36 is 9 times 4, or you could think of it as, yeah, I'll probably go 9 times 4 if you want, or you could have gone 18 times 2, but we'll go 9 times 4, I think is better. Okay, now we're going to continue over the page. Now, look, most people would think of different ways to do it, so any two people probably not going to do the same thing here. So we're going to break up this log to the base 10 of 9 times 4, which would be log to the base 10 of 9, plus log to the base 10 of 4. Now we don't have the values for 9 and 4, but remember that 9 is 3 squared and 4 is 2 squared. So this would be 1 plus, remember the power comes to the front, 2 times log to the base 10 of 3, plus, and this 2 comes to the front, 2 times log to the base 10 of 2. And now we can substitute. So log to the base 10 of 3 is approximately 0.48, and log to the base 10 of 2 is approximately 0.3. So now adding all that up, we should get the same answer, 2.56, which is what we had before. Okay, so that's 2.56. Now, of course, there were other different combinations that you could have used, just showing that it doesn't matter which way you go, many different methods to get to the same place. Okay, and the last one is log to the base 10 of 1 on root 10. Okay, now, so we know that this is log to the base 10 of 1 over 10 to the power of a half. Now I could have done it other ways. This is just one method. So I could write this as log to the base 10 of 10 to the power of negative a half. This is probably the quickest way to do it, okay? So square root of 10, you need to change that to 10 to the power of a half straight away. 1 over 10 to the power of a half is a negative power, 10 to the power of negative a half. Now the negative half can come to the front, so it's a negative a half times log to the base 10 of 10. Now we know that log to the base 10 of 10 is 1, so it's just a negative half times 1, which is negative a half. Okay, now another way you could have done it is you could have written log to the base 10 of 1 on root 10 is log to the base 10 of 1 minus minus log to the base 10 of root 10. And then you can start working with that. But if you're going to use that method, you have to remember that log of any base, that you need to remember that log to the base a of 1 is 0 to use this method. So we've got log to the base 10 of 1 is 0. Remember that log to the base 10 can be done on your calculator as well. So you just press log 1, you get 0, minus, now this is log to the base 10 of 10 to the half. Now again, the half has to come to the front. So it's 0 minus a half, log to the base 10 of 10. Now we know that log to the base 10 of 10 is 1, so that bit's 1, so it's 0 minus a half times 1, which is 0 minus a half, which is negative half. Again, same answer, just a different method. 14, and these might be a bit challenging. Now, if x equals log to the base a of 2, and y equals log to the base a of 3, and z equals log to the base a of 5, we have to simplify each expression, and the first one is log to the base a of 1 on 30. Now, let's write this with a negative power to start with. This would be 30 to the power of negative 1, because remember, 1 over means negative power. So let's put this negative 1, let's move the power to the front, so it's negative 1 times log to the base a of 30, which is just negative log to the base a of 30. That's just negative log to the base a of 30. But what we're going to do, instead of writing 30, we know that 30 is 5 times 3 times 2. So it would be log to the base a of 5 times 3 times 2. So that is negative of, now I'm going to put a bracket here because it's the negative of all that. It's negative log to the base a of 5. So let's just keep this negative out the front, all right? Plus, so when you're multiplying, you plus log to the base a of 3 plus log to the base a of 2, which is the negative of, now log to the base a of 5, or of 2, is x, log to the base a of 3 is y, log to the base a of 5 is z, so I'm just going to write it the other way around. It's the negative of, in brackets, x plus y plus z, or it's negative x minus y minus z. Okay, we're going to try another one here. Question C. Log to the base a of 27a to the power of 5. Now it looks like the power of 5 only relates to the a. So this would be, we need to break these up first. So this is log to the base a of 27, because there is really a multiplication symbol there between the 27 and the a to the power of 5. So it's log to the base a of 27 times a to the power of 5. So that's log to the base a of 27, now using our log law, plus log to the base a of a to the power of 5. Now 27 is 3 cubed, because we're trying to write it as log to the base a of 2, 3 or 5. So that would be log to the base a of 3 cubed plus, now here I can bring that 5 to the front, so it's 5 times log to the base a of a. Now this 3 can come to the front, so that's 3 times log to the base a of 3 plus 5 times, now log to the base a of a is 1, so this is 3 times, now log to the base a of 3 is y, so it's 3y plus 5 times 1 is 5, so it's 3y plus 5. More examples here. So we have to simplify log to the base a of 18 over 25. So we'll use our subtraction rule. So that's log to the base a of 18 minus log to the base a of 25a. Now, we know that 18 is, so this one's a little bit trickier, all right? We know that 18 is 2 times 9, so it's 2 times 3 squared. So we can write that as log to the base a of 3 times, I'm going to write it as 2 squared to start off with, minus log to the base a of, now here I've got 25a, which means 25 times a, because I need to break that up, okay? So this, I can use my rules now for multiplication and addition. So it's log to the base a of 3 plus log to the base a of 2 squared minus, now I need to take away all of this. So that's going to be log to the base a of 25. If I put a bracket here, I can write minus, and then I'm just working this out. This is log to the base a of 25 plus log to the base a of a, and close my bracket. I'll open my bracket up in a minute. Now, this is log to the base a of 3 plus, I'm going to bring this 2 to the front, 2 times log to the base a of 2. Now I'm going to remove my brackets as I do this. Log to the base a of 25 is log to the base a of 5 squared, and I'll keep my bracket actually, and log to the base a of a is 1. So now I'm going to remove my bracket in the next step, and I'm going to start substituting. Now log to the base a of 3 is y. 2 times log to the base a of 2. Now log to the base a of 2 is x, so it's y plus 2x, minus, now I'm going to open my bracket up, but I'm going to bring this 2 to the front. So it's 2 times log to the base a of 5, and opening up the bracket, I get minus 1. So we're nearly done. It's y plus 2x minus, now log to the base a of 5 is z, so it's minus 2z, so that's 2z, take away 1. Right, that was a little bit tricky. And now for the last one, I'll just, I'll just work over here. So log to the base a of 4 over 100. Now we know that that is log to the base a of 4 over 100. Now let's simplify 4 over 100, which is 1 over 25. Now we know that 25 is 5 squared, so we can do that. That's log to the base a of 1 over 5 squared. But before you go bringing any 2 to the front, I need this to be x to the power of n, so I need to write this as a negative index, so that's log to the base a of 5 to the power of negative 2, because 1 over is negative power. Now I can bring the power to the front, so it's negative 2 times log to the base a of 5, and we know that log to the base a of 5 is z, so it's negative 2 times z. Okay, and that's the end of the examples.